researchers, etc. And I want to start, and I have started interviewing abductees, people more on the UFO phenomenon side of things. And actually, it's funny that we're doing this. Literally 2 hours ago, I basically started a UFO research nonprofit a year or two ago with another abductee named Zach Agee, and I actually just did an interview with him as my first one like 2 hours ago.
Oh, nice.
Um, you know what's cool? Yeah, I'll send you the video when I release it with him within the next day or two. He has a gray patch on the side of his head of hair,
Yeah. Does he have
which
another one on the back?
I don't think so. I don't think
Okay.
so. And I asked him about that, and I was like, "Yeah, Zach, I spoke with this guy Sean, who's also an abductee, and he's got this gray patch, and it was really cool. So I'll send you that. You might find it interesting.
Very cool.
Have you spoken to or like met other abductees?
Not yet. No.
Really? Would you like to?
Yeah, I would love to. I'm trying to get into the community more. I want to become a voice. I potentially could become a leader in the space. And I want to really try and bridge that gap, like we talked about last time,
Yeah.
about how the misinformation is being driven from both sides. And so we all, as abductees and experiencers, we all argue about who's right. And we need to stop doing that and accept the fact that they have better technology than us, and accept that we're all telling the truth the way that we understood it, and then seeing where those when we overlap, where does our experience make sense? Like, how does it make sense if we combine everybody's together? Then now how does it make sense? You know what I mean? As opposed to like arguing over, well, I'm talking to this species, or I'm talking to that species, or my communication is this way, and being so definitive about it, like we need to have the answer. I think it's smart if we just accept that we don't know what's going on 100%, and then bridge the gap with science, and bridge the gap with like shared common things like the gray patch, right? Like if I have a gray patch and he has a gray patch and other people have a gray patch, okay, well, let's go get a biopsy done on that tissue sample. And what does that mean? Are both of them from, a microwave radiation exposure? Well, okay, now we have repeatable evidence that is now linked to two people and so now we're starting to bridge our gap on our, like we're all waiting for the government the big brother to come and say, oh, hey, everyone, aliens are real, right? But we don't need that, because if we organize together, we have enough data. We just have to stop arguing with each other. And I think that's what the disinformation campaign has been, is to get us to argue with each other, right? By seeding the disinformation, by seeding the lack of the doubt and ridicule from people, the stigma. Well, what's the return on stigma? Well, the return on stigma is that people are going to question you. Well, if they question you, then you're going to need validation. And so we all seek validation. And so it's working. And we're playing right into their hand of stigma, right? And should we be? Well, I don't know. I don't think that we should be. I think that we could organize and be smarter than that, right? But we need to stop arguing. Like our leaders right now, all they do is argue. Like Stephen Greer spends his whole time telling everybody else that they're wrong, and he's the only one on earth who knows what's going on. Right? And then you get Jeremy Corbell doing the same thing. Ross Coulthart's kind of doing the same thing. So all of our people who are kind of rising to the top are really kind of inadvertently or unbeknown to them, they're just driving the stigma even further and making it even harder for us to organize and pull this out from the other side of the spectrum, which I think is kind of what the Defense Department or the intelligence communities needs. They've been waiting for us to kind of organize, right? Like they're trying to flatten the curve. They give us a little sample, and then they want to see what we do with it. And then they give us another little sample, and they want to see what we do with it. And they just keep giving us these little things, and they're waiting for us to kind of like, take off on our exponential trajectory, because we're going to do it at some point. We're going to get validated, and people are going to start listening to experiencers, and they're going to go, wait, aliens are here? Holy shit, well, what does that mean, right? And then, like, you talk to them, what does that mean? And then they're going to start doing their own investigations. And when that happens, it would be really nice if we were all organized in a way where we're like, you know what, well, I can't talk about the other experiences, but my experience was like this, right? And take from it what you like. Probably some of it is disinformation. I'm going to tell you that up front, right? And not every one person has all the answers. You know what I mean?
Yeah, I think those are all great points that you make, and I do want to touch on the idea of stigma. I'm completely on the same page. I think that the correct course of action is to lean into the stigma, and when you have, because my thought is essentially when you have data on your side, you almost decredit yourself when you, I guess, care too much or fear the stigma, right? Because then it almost signals a lack of confidence, and a lack of confidence signals to people that you're uncertain or you don't know what you're talking about. I think that when the data's there, in my field of research with the precognition stuff, the data is absolutely there and it's provable. With the alien abductee phenomenon, with individuals like yourself, the amount of evidence and the amount of experiencers and the amount of cross corroboration is massive. I think the correct course of action is absolutely to lean into it unapologetically and to speak the truth, and the truth will prevail. So I'm completely on board with that. And one other thing, I mean, this is the second time I've spoken to you. You come off to me as an incredibly intelligent and credible person. So I would love to see you continue to make your voice heard as it relates to this topic. And I think that you'd be a wonderful spokesperson for experiencers and the phenomenon.
Awesome. Well, thank you for that vote of confidence. I appreciate that.
Yeah, for sure. So, I mean, I picked your brain a little bit the other day about your experience, but the people watching this won't know much about it. I mean, I think you have some materials online where you go over your experience. If you want to just start from the beginning, and if you want to kind of lay out what happened to you, I'm all ears.
Okay. So at the beginning, it's kind of lackluster. My abduction experience is kind of the least interesting aspect of my abduction, if I'm going to be frank. I was in Mexico, got it from the table at a restaurant, went outside, and then boom, the whole world went black, like the space before birth. And I was gone. I had no. And then I came to, and I'm outside of a hotel room, and I've been drugged because I can't talk. I pulled a phone out of my pocket. My phone is dead. I have no money, no keys, no nothing. All I have was a room key. And I go to the concierge, who's the first human I've seen in what I later find out to be hours. I'm ultimately missing 12 hours of my life at this point, but I don't know it yet. Because in my mind, 10 seconds ago, I was at the restaurant. And I hand him my room key, and he's like, "Oh, Senor Long Way," and points down the road to my hotel room. I had no money. I had no way to get anywhere. And I found out when I got back to the hotel room that my friends had spent hours searching the area of Cancun where I had gone missing. And so my whole abduction experience is basically just like missing time, right? So I know that I got taken. I know that I got taken somewhere. I know that afterwards I ended up with these gray spots on my head.
Do you want to show the camera?
Yeah, it might.
It's the other. Isn't it the other side?
No,
Yeah,
I'm
there you
pretty
go.
sure. Is it? Is
Yeah,
this
yeah,
side?
yep,
Okay.
yep. You
Yeah,
can
there's
see it.
one here, and then there's another one at the back, and that's where the intersecting laser took me out. I believe now, from what I've put together through the science, that I've kind of figured out how they do stuff. Kind of like they make crop circles, and they just have an intersecting laser. Boom, took out my pawns, overloaded my system, and knocked me out. And then they tagged me with this implant, which I later discovered through trying to get medical evidence, trying to figure out what was wrong with me, and ultimately going through a psychiatrist who recommended to my doctor that I get an X-ray or an MRI, which then led to an X-ray, which then led to an EEG, which then led to the plethora of validated evidence of this thing's existence and its RF interaction, radio frequency interaction with the world through multiple different sensors and sensor inputs. So, like, that's my abduction experience. But what's really interesting about my case is that months after my abduction, I started hearing voices. And the voices would ask me really interesting questions, like, why would you drive your dog to the dog park to take it for a walk? Like, wouldn't it make more sense to like walk your dog? You know what I mean? Like really weird stuff. Taking the piss out of me. One time they commanded me to go online and look at the Canadian budget because the budget was being released. And like, why would... And so they would ask me these really strange questions. But then as time went on, they started teaching me. They started teaching me physics. They started teaching me astronomy. They started teaching me philosophy, communication, sociology. And we would have the most in-depth questions about like the root reason for like desire, or the root reason for like motive, or like how humans behave in a certain situation. And so it really started to take on this whole new dynamic where I started learning, and I started learning what was happening to me. I started isolating the signal. I started tracking down and figuring out where the signal was coming from. And I was able to not only measure the signal through the device, but I was also able to find some protection from it by moving into a condominium, which had many layers of concrete above me. And that gave me enough of a buffer where I was able to then continue living my life in a more normal manner and getting control of that sort of stuff. And so I've just been, I think the really compelling part to my case is not only the physics and the science and the computer science that I learned through them, was they've been very open with me about their motive and who they are, and like where they came from and what their culture's like and what the rules of their culture are, and who they are and why they believe the things that they do, and like all of their like cultural experiences. And they let me argue in their computer. So like there's been nobody representing humanity in their computer, not in a real way where they understand their culture and their values. So what they do is they have 100,000 plus whatever, however many sensors of these. There's 100,000 experiencers out there who are data points. They're collection points for their computer, and their computer's collecting this data so that they have a chat GTP project of Earth and humans. And so when they open that project up in their AI, they can have conversations with vectored humanity. So they can say, what do humans think about, some experience, slavery, right? And humans would then say, the computer would then respond as the vectored humanity, oh, humans dislike slavery. Or what do we think about dictatorships? And then they could have a conversation with vectored humanity on dictatorships or leadership models or philosophy or whatever. And they gather this data through the conversations that we have with other people, right? And so we're all just a data collection point for the computer so that it can represent us in what I like to call the halls of Valhalla. Because in Viking times, the great warriors, after they died heroically, they would be elevated to the halls of Valhalla. It was a place of recognition for humans. And so I like to play on that when I talk about this. But yeah, so that's kind of the whole interesting part about my experience. And I think the most valuable asset that I gathered in my time was the motive of why they're here. And I think the motive is the strongest point because it makes sense with all data points. It doesn't need any support of any kind. It follows a linear progression that we're going to take. Like if you project our timeline forward 1,000 years, we're going to be doing exactly the same thing that they are. Mm-hmm. And I don't think there's a person who knows anything about science or has done any research at all that would argue against that position, right? So, I mean, eventually we're going to create fusion, and we're going to hone it, and we're going to figure out how to have a net positive fusion reaction, and we're going to start pulling energy from fusion. Fusion is when you fuse two hydrogen atoms together to make a helium atom. And every hydrogen atom that you fuse is gone forever. So where are we going to get the hydrogen from? Our water, probably at first, and then we're going to watch the oceans go down by 6 feet. And we're going to go, oh, hang on, maybe that's not the smartest idea, because if we continue this process for the next 10,000 years, eventually we'll have no ocean. Okay, well, we have to get our hydrogen from somewhere, and we're going to look up to the stars and we're going to go, oh, look, there's 4 huge gas giants here. What a fortuitous situation we have. And we're going to go, okay, well, let's start pulling hydrogen from Jupiter or Saturn or Neptune or Uranus, right? Because they're such a huge, massive store of hydrogen. So if it makes sense for us to do it, well, then it makes sense for them to do it. And
Yeah.
they told me that that's what they're here doing. So not only is it congruent with the narrative that I've been given, but it also makes perfect sense from a scientific standpoint, from an energy standpoint, from a sociology standpoint, from a ancient aliens standpoint. All the structures and megalithic structures we see all over the world. Now there's a motive for that.
Mm-hmm.
Well, why would they do that? Well, because they were trying to guide us. They were trying to teach us. They maybe possibly gave us farming. They possibly gave us writing. They possibly guided humanity along through our journey, right? Watching us come out of the last ice age. It now gives them a motive to be here, and it solves the physics problems that a lot of our leadership, and I mean like political leadership, struggle with when they're talking about this. Because they talk to their physicists, and their physicists are saying, oh, well, the only way that they could travel this far is if they've got warp drive, or they can travel through time, because the distances in space are too big. But the distances in space aren't too big if they're at Jupiter. It's only 35 light minutes away. That's a couple months or a month. Or if they travel at 100 times the speed of sound, maybe it's a few weeks for them to get back and forth. Well, now, like, we would totally put somebody, I mean, we do it right now. We put people on the North Pole, we put people on the South Pole, we put people in submarines for months at a time. Now this becomes just a work term, right? Instead of a total sacrifice of life. Because even if you're at the closest star, like, and we don't think that the closest star has got habitable planets, but let's say you're 4 or 10 light years away. Let's say that their home planet is that close. That would still take them an entire lifetime to get here with any known physics propulsion systems that we can even conceptualize, let alone build. So, I mean, it just takes so much extra math and physics and creative, ideas or postulations in order to get them to close that distance in a way that makes sense from a biological standpoint, right? So then that divides the problem. Are we dealing with an artificial intelligence, which is why I think they call it NHIs, because they're not 100% sure that it is an actual biological being that's here. It could be a representation of a artificial intelligence, and I don't know with 100% certainty, but I have it with like 95% confidence, which I think is pretty high. And the reason that I have that level of confidence is because they make mistakes. They say things that they make little slips. Not all of the information that I have was necessarily a gift. Some of it was I caught a mistake or an accidental truth that I put together with another accidental truth. You make a comment about your eyes or the way your brain works, or they show me how quick they can recover from an emotional experience, like they get angry. This is one of the things that's really cool about them, is their emotional secretions are different than ours. When we get mad, I mean, it takes us 20 minutes to calm down. People get really upset, they'll go fly off the handle. It takes them 20 minutes, half an hour. Sometimes people have to leave and go for a walk and come back with a calm mind. They don't do that. They don't need to protect that space, if that makes sense. So you can imagine if you could go from 0 to 60 and back in like a minute or 2 minutes. You wouldn't need to protect that. Don't make me angry. Like humans like to threaten. Don't make me angry because I'll lose my cool. They just fly off the handle left and right for any given reason. And so it's really interesting. And I kind of feel privileged to be a part of their culture for as long as I've been communicating with them, and to see their side of things. And it's been a really interesting experience culturally,
Yeah,
to experience that alien culture.
Yeah, I'd bet. So a few things I do want to go into depth on. I want to go into depth with your communication, the knowledge you've gotten from them in terms of their technology, their motivation, their history, how they interact with humanity, all of that stuff. But just for the people listening, because I think that it's important for a general audience to get a perspective on this stuff, I want to ask a little bit more about you personally, right? So if you wouldn't mind going into a little bit of depth about your, life experiences before this, maybe your childhood, what you did professionally then, what you do now, how old were you? What year was this when you had this experience? Like just kind of the timeline before the abduction happened.
Yeah, so I grew up in a small town in northern BC in Canada. Um, and I went to high school, went to university. I took engineering. I didn't succeed in my engineering class. Ended up dropping out. Started doing construction for a while. Took ended up getting my mechanics ticket, and I was a heavy duty mechanic. And when I got abducted, I was working as a heavy duty mechanic. My career progressed. I became a supervisor, then I became a manager, then I built my own shop. And so I've owned and managed businesses throughout my life. But like I'm not anyone special. I don't have any special like degrees or anything crazy. I've always taken a lifelong interest in physics and learning, and chemistry and all of those things. And so like I get it. I always watched and liked to learn about particle physics and quantum mechanics, and I always kind of kept my eye on things. So I've always just been someone who's just taken a fascination to the world around us and how it works. And so I don't think my qualifications really play into this much at all. But my abduction happened close to 15 years ago. I think it was, and I don't remember the date exactly. It was in 2010 or 2011. I know the year because it was the first year I won my fantasy football league, and it was the money that I won from that trip that sent me to Mexico in the first place. And so I have the date. I just don't keep it. It's not relevant enough information for me to keep that date. But it was sometime in February in the fall, or in the winter, and yeah, and then it just like the whole thing just kind of progressed. So now I am trying to leverage my experience and the information that I've created or that I've been given or taken or whatever you want to call it, to create a new business, ultimately open source everything and give everything that I've been given by these people to humanity. I've got a new model of the atom that works. I got a new antenna that potentially has got the potential to absorb heat and give us electricity right out of the atmosphere. So it would be a direct solution to global warming. Communication, wireless communications, and all kinds of stuff with the brain. I know how the computer-brain interface works. I know Elon's doing some stuff where they put sensors inside your head. And what I'm trying to do is create this antenna that will allow me to do wireless interaction the same way that they do. And he uses a very similar technology to the way that they make crop circles, which is just basically intersecting microwaves. And amplitude and phase is done right so that the peaks peak at the same spot, and it can come in from multiple angles, and then they can generate a large enough amplitude that it affects the stalk of the wheat or whatever product that they're creating crop circle in, and it doesn't affect any of the other plants that are around it. And they do the same thing. They at least they told me they use the same technology to cure like brain cancer and cancer in their body and do all kinds of treatments. And so if this technology works, it's actually a non-invasive solution to cancer.
So I want to clarify, and I want to dig into this from a technological point of view, and I want you to correct me if I'm wrong. I just want to illustrate my understanding of this. So they have multiple different, EMF or radio wave or microwave or whatever it is emitters that go from multiple different angles, 2 or more, and they calculate it as such so that the peaks of the waves hit at a certain point of interest and they constructively interfere, so it creates like a higher amplitude at that specific point.
Exactly.
Is it from 2 sources or 3, or how many sources? Does it matter? Can you use different
It doesn't
numbers?
matter.
Okay.
You can use as many as you want to, but you have to have your phase and your polarity right, so that you have to be controlling light in a way that now you're deciding what happens instead of having the light kind of decide what happens, right? And so it takes this different type of antenna in order to control light the way that they can. And they can control light implicitly, which is how they're able to take an invisible position. That's how they're able to disappear from radar. That's how they're able to do everything, because they use nanotechnology, these little tiny little antennas at the nanoscale to control the reflections. It's like a goalie in hockey who controls the rebounds, right? A good goalie controls the rebounds. This light, it's like our stealth bombers. They don't want any light bouncing off of it. So what they do is they just absorb it all. And then they re-emit whatever they want you to see. So these objects can take on the shape of a circle with a black square inside, or they could look like, an old man or a dog or a car or a bus, or they could make it look like anything that you could project onto a TV screen, right? They can make it look like the background. They can make it look like anything. And then because the surface is contoured in a three-dimensional way, it can look like that from any angle, right? And so if I'm looking at it from here, it looks like it doesn't exist. And if you're looking at it from this angle, it also looks like it doesn't exist, because they use like a cube or a pyramid type surface on the outside. So I don't know if anybody's actually seen one of these things up close, because I don't think that the gifts that they've given us, the crashes that we have, necessarily replicate the same thing that we're seeing when we see a lot of the stuff that we see out there, right? Like there's different levels. Like they've given us some stuff to reverse engineer. They've given our leadership of multiple countries. I think I asked Grok one time, and it said there's been over 100 crashes that he could find all around the world. Like you got to think China, Russia,
All over the place, Africa,
all over the place.
Yeah.
And so their crash rate, if you do the calculations, is insane. So that doesn't make any sense. It makes way more sense that, okay, we gave you a gift, we're going to give you a gift, and everybody gets to reverse engineer it. And we're going to make fun of how crappy you are at trying to understand our technology. And we're going to say, you've had this stuff for almost 100 years now. It's been 80 years and you guys still don't understand this. And we're taking blowtorches to their like nanotechnology, and we have no idea what we're doing, right? But some progress has been made. We see lots of progress in our science and in our technology. We have electron microscopes, so we can go down and look at stuff using the electromagnetic field as a kind of some semblance of knowing what's going on down there, right? And so it's really interesting to see. And I mean, the rabbit hole just goes deeper and deeper and deeper. The more you see, the more you discover, the more pieces of the puzzle you can put together, right? So it's really cool.
Yeah, that's super fascinating, and I could think about and ask you follow-up questions about that technology forever. Another thing I do want to hit on from the technology point of view, because we spoke about this in our conversation the other day, is your model of the atom. And you've essentially, theorized or gotten this information from them on basically how to unify the fields and connect electromagnetism with gravity, quantized gravity, whatever you want to talk about. So if you want to lay that out, I found it incredibly fascinating, and maybe someone who's smarter than me, who can derive more insight from it, will listen to this. If you want to lay that out, that'd be perfect.
Yeah, I'm also looking for somebody smarter than me, who understands this stuff, who can, validate me and have a real discussion about this in a real way. Because like, I've tried talking to people about this, and most of the people that I interact with don't have the level of physics that it takes to get through this. So I've been leaning hard on Grok, and I've been leaning hard on the AI to try and help me understand this. But in my best understanding is, we had a model of the atom that we've had a bunch of models. There's a pudding model where they thought it looked like pudding, and then, and there's a progression that goes through. And the one that we used to do all of our chemistry was the Bohr model of the atom. And so the Bohr model of the atom is the part where there's, a proton, and then there's electrons orbiting around this proton, and then there's free electrons and two, an outer shell, an inner shell, and we have all these shells. Well, then they got rid of that when they started measuring stuff, and they said, well, that's close and it works with our chemistry, but it doesn't really, fit some of the other measurements we're taking that we're seeing in the real world with our, now that we're able to zoom in with our electric fields, and now we're able to measure things electronically instead of just like seeing things on a steel plate and all this other stuff, because most of that science was done in the 1900s. So as we've advanced our technology, I think Schrodinger came up with the Schrodinger equation and to solve for some of this stuff in 1924. And so they came up with the Schrodinger equation. And the Schrodinger equation makes sense with the math, but it doesn't make sense from a logical standpoint. So that's where we get Schrodinger's cat, where Schrodinger's cat is in the box and it's not in the box at the same time. And the way that they do that is they say, well, we don't actually know where this orbiting atom is at any given moment, but we can narrow it down given a time location to say that it's probably in this quadrant, or it's probably in this section. And that was a fix that we made. We kind of like shoved it, or we forced it. It's a correction that we made to make the Bohr model of the atom work, because we like the Bohr model so good because it works really well with our chemical formulas. We know how to make chemistry. Look at all the drugs we have. Look at all the cool stuff we've created. Look at all the air conditioning examples that we have. We have so many different combinations of chemistry. We've worked through all these different ways to create chemistry. We can predict it. We understand it. It's something that we understand very well. So to say that there's this new idea that breaks all of that is very counterintuitive. It's like it would be a hard left turn, right? But what I was given was just a correction for that Schrodinger adjustment. So instead of there being probabilities, there's just light. And we know that the universe is just light because, we're smashing particles together. And when the particles disintegrate, they turn into these other measurement artifacts that we've now turned into quarks and all this other stuff, right? Which is a way of us interpreting the readings that we're getting from our electromagnetic sensors and turning them into these formulas that we've managed to create. But what we've done is we've taken an assumption and then we measure it using that assumption as our formula. So it's like imagine that you're a dolphin and you're underwater and you're checking to see if your fin is wet, right? Well, of course it's wet because you're surrounded in water. So there's this cool meme where they say you touch your finger never touches because the atoms don't actually touch. There's an electromagnetic field around my finger here and another one over here, and the two outer electrons just repel each other, and we feel that as a force, right? And so everything is just a force, so everything is light. And if everything is light, well, it just changes things ever so slightly so that instead of there being electrons orbiting, which is very complicated and difficult for us to do, it's just layers of light around a proton. And if there's layers of light around a proton, everything can be true. It doesn't need the probability matrix to exist. Because if I have an atom and I take a measuring point over here, my measuring point works in the electromagnetic spectrum. It works on electricity. So it's like I'm a dolphin underwater. I'm trying to measure the electric field using an electric field, right? There's no outside frame of reference to which we can say zero is, right? Like we don't know where we don't know where the zero of electricity is, electromagnetic zero is. We can predict it with our math, but we've made all kinds of assumptions in our math. And the real problem with our version of physics isn't just the probability matrix that the Schrodinger equation forces us into, where there's stuff that exists and doesn't exist at the same time, which is counterintuitive. And the wave-particle duality, which this also solves, but it also solves for gravity. Because gravity in their model is just the proton. And so if the proton becomes a gravitational field, it basically is like if the electron is negative, the proton is positive. It's the opposite force. And so they're attracted to each other. But they're attracted to each other in a way that's in balance with all of the frequencies and all of the levels of pressure and all of the levels of electromagnetic balance that's in the universe. And so the majority of our experiments have been done on Earth. And Earth has got a gravitational constant of 9.81 or 9, I don't remember, it's been a long time since I've looked at it. But I think it's 9.81. Force of gravity is the force of pull on Earth. Well, that's a pressure of pull that all the protons on Earth are pulling together to pull the light in, to pull all the other stuff in. We haven't done any experiments in zero space because we don't have the technology to do that. So we can't change the default electromagnetic pressure in a system. We can create a vacuum, but we're not changing the amount of light that's on it. And so it's just a solution to a problem that I'm not even sure I fully understand, and it's something that I'm working on, is trying to go through that math and understand exactly where it is. But it all boils down to one experiment. And there's one experiment that we did, well, there's two, but there's one experiment that really hits home, and it's the black body experiment. And so the black body experiment is the experiment that we did that proves that there's a quanta of light. To say that, an atom will only absorb a certain packet of light, and it goes from one energy state to another energy state, and there isn't like you can't take a half of a photon. You have to take like a full photon in order for it to absorb. It's either going to take the full photon or it's going to take zero, right? And so the black body experiment allowed us to prove that the quantum existed, which led us down the whole pathway of quantum mechanics. But when we did the black body experiment, I think we missed out on the fact of the sum of energy has to equal 1, because they made a prediction of the ultraviolet catastrophe. So they were expecting that the light, so they shine a whole bunch of heat and light into this hole, and it goes into this box, and the light bounces around and bounces around. Eventually, the box absorbs all of the light, and it converts that light into heat. And when they did this experiment, they did it in the late 1800s and early 1900s. So there was no spectrum analyzers. We didn't even necessarily understand the full spectrum of light. We were coming up with formulas and trying to understand stuff, but we didn't necessarily understand it in the way that we're starting to understand it now. And so when the sum equals 1, the light going in has to equal the light going out, right? So if they're putting energy in, it has to equal the energy going out. And they predicted that the ultraviolet light that was coming out would peak infinitely in its wavelength to infinity, and that didn't happen. They measured something else. And I think what they were missing was that there is a quantum state of matter. I don't know, I'm probably going way down too deep in this, but I think that experiment is the root of where we started making assumptions, and then we started using those assumptions to make new assumptions. And so then there's one root assumption that we made that kind of makes it so that gravity comes from the proton, and that's the ultimate solution to all of this. And we're seeing a lot of this stuff, like we know that light bonds matter, so you can create bonds in matter using intersecting light, and you can break bonds in matter using intersecting light. They're redefining what temperature is, because we always thought of temperature as being like heat, and heat is intrinsically different than light, even though it emits on a certain frequency. And now we're starting to understand that it's all the same thing. And so in our Bohr model of the atom and our chemistry, we wanted to use like water hydrogen plus oxygen plus heat equals water, right? Well, it isn't just heat. It isn't heat as a variable. It's a very specific frequency that is used in that bond. And if you create hydrogen and something else, it's another, now the spectrum of light changes. And from the conversations that I had with them, you can utilize that heat value. Instead of using heat as a value in that chemical formula, if you change that to a frequency of light and you expand that heat block or that heat method, and we open it up into a series of, a series of formulas, you can get into using the spectrum, emission, and absorption lines. You can now very precisely decide the bonds in matter, and you can create bonds in matter, you can destroy bonds in matter. And when we hear about them traveling faster than the speed of light, here's a real world application of this. They travel faster than the speed of light and they don't make a sonic boom. Well, why? Because they're ripping apart the air using a frequency of light just before they go through it. So they're cutting it like a hot knife through butter, and now all their ship has to do is just push that light aside. Where we build this huge pressure force, and now we force a ripping of that stuff. And that comes from the energy of the ship, which creates a vibration, and everybody knows that sound is a vibration pressure wave that goes through the air. So now this buildup of pressure, this buildup of thing creates a sonic boom. Well, how do you get rid of that? You just stop that buildup of air on the front by cutting it. And so they can travel through the water at hundreds of knots, and we don't understand why. And we don't understand why because our chemistry is not complete. We're using heat as a function. And I think I just read something the other day about, they're like, oh, we're redefining heat. And I'm like, yay.
We're catching up.
That's really cool.
Yeah.
Because hopefully that all fits in what I've been given to put all this together in a mathematical way. But I'm just a mechanic who takes an interest, a casual interest in physics. I'm not a physicist. I'm not a particle physicist. I don't get paid that level of stuff. I don't have the formal training. So for me to sit here and say that I understand this implicitly is ridiculous, right? I need help to understand this. And I've put out invitations to people, and I'm trying to get my name out there to, to get attention, to ask the question, to challenge the stigma, to put science to this. Can we explain it mathematically how they prevent a sonic boom from happening? And I think that we can. Can we explain how they travel underwater? I know in the Age of Disclosure, there's a Air Force scientist who's talking about pushing a basketball through the water at 200 or 300 knots. And he's like, it would take a Bezos 3 rocket engine to push that basketball through the water. Well, you're making the assumption that you're using the same fluid dynamics that we understand, right? But if the bonds were split, well, then it probably wouldn't take that much energy, because how much energy is going into just breaking those bonds? You know what I mean? Does that make sense?
It does, and that's all great information. Yeah, man, we got to get you in contact with like an Eric Weinstein or someone like that, and I think it's gonna happen. So let me just get this straight. So when we spoke the other day, and you were telling me about your model or their model of gravity and how it's really just the proton, and then you just spoke about how they're manipulating light. That seems to be kind of the core of a lot of their technology. When they're doing this faster than light travel, they're not manipulating gravity, they're manipulating light. Is that correct? Can you give me a little bit more insight or understanding there?
I don't think that they've achieved faster than light travel. I think that is an assumption that we've made. I think that's because I'm not sure if our leadership knows their real motives. I don't think that they've been fully upfront. The EBEs, the extraterrestrial biological entities, and I like to use that word instead of NHI, because I believe that and I don't know this, but I believe that the people I've been talking to are EBEs. I don't think that they necessarily want the information of their motive being made public. But I think that it's really important that it does become public, because I think it solves for so many problems. Like, they don't need to travel faster than the speed of light, right? It could have taken them 10,000 years to travel from their star. They didn't need to be alive while they were on their ship. We can synthetically create life. We've been cloning sheeps. I don't know this, but just as being a human, for sure someone on this planet has cloned a human somewhere
Oh,
in a
totally.
lab
Yeah, China somewhere. Yeah.
like illegally. It's been done just to know that they could do it. So if we can do it and we're at our level of understanding, we haven't traveled to another star. We haven't even sent a probe to another star. Our Voyager 1 and Voyager 2 are just leaving our solar system. They hit a big wall of heat that they didn't even think existed. So we're learning about the universe in ways that we haven't even doesn't even make sense to us. So imagine where we'll be when we've traveled to the closest star, or the 10 closest stars, right? 10,000 years from now, where will our technology be? Would we be able to send a ship to another planet 10 light years away with seeded humanity on it, ready to be born when it gets there? Of course. So now you don't need somebody to be alive in a ship, like flying it, right? They could come here and be born and start a new colony here where the energy is.
So it's like a von Neumann machine, essentially, where they're not traveling themselves alive, but they send the technology to basically reproduce their version of life once it reaches that place.
That's right.
Interesting. Yeah. That's fascinating. So I know we spoke about this last time, but if you want to go into more depth about a little bit of their history and what they've told you about that, why they're here, how they interact with humanity, all of those, later stage details, that's perfect.
Yeah. So the narrative that I've been given is, and it makes perfect sense, is that, they went through the progression of fusion like we did. And they looked to the universe and they said, okay, well, we're going to need a sustainable hydrogen source. And hydrogen is the most abundant resource in the universe. So they looked at their telescopes, and remember, their technology was probably more advanced than ours when they did this, because we're not ready to do this yet. So project us forward 50 years, let's say. They look out in the universe and they start looking for gas giants. Well, where are we going to get hydrogen from? Where's hydrogen in its most readily available state, where it's going to be the easiest to farm, right? Where it's going to be where we can just take it and it's not going to hurt anyone and it's not going to take from the universe. Well, gas giants have already done all that. Jupiter is a massive star that just barely wasn't big enough to start fusing. That's what we think. So they looked around, they went, wow, that solar system over there has got 4 huge gas giants. Why don't we go there? That'll be enough energy to sustain our civilization for millions of years. So rather than doing a round trip, because it was a long way of sending tankers like we're going to do because we're close, they decided to leave their planet. And so they evolved into space. When you look at the astronomy and you think about the astronomy that I've been afforded, and you look at the solar system as a whole, you see that all the stars are all attracted to each other in our galaxy. And so they're all turning at different speeds. They're all accelerating at different rates. Nothing in our galaxy is in balance. And that's reflected by the stars. If you look at the stars, 40% of them, I think 40%, I'd have to check Grok, but 40% of the stars are in binary or trinary systems. That means that all stars in our galaxy eventually collide and become a binary trinary system. Well, a 3-body problem doesn't exist. So if you have got 10 planets or 2 planets or 3 planets rotating around your star, orbiting around your star, and it collides with another star, now your gravitational balance just got thrown out the window. So that means that eventually our star will become a binary system and all of our planets are going to scatter. And there's some science about what that looks like when our star burns out and how our planets disappear. I think I have an example of that on my channel. But so the planets are just going to disappear. So if you push the timeline far enough in your planning of the human species, eventually we're going to have to sustain life that's not on a planet, or at least not on this planet. And so when you realize that, when you have that realization, you go, okay, well, if planets collide, like our moon, we know that our moon was a giant body that slammed into Earth, and we think that it was formed, and that's why they're tidally locked, and it's locked, right? And we can see Venus is in retrograde. We can't explain Venus, not through normal mainstream science. But this explains it perfectly. Venus came from somewhere else. It's spinning retrograde. It spins in the opposite direction than all the other planets on our system. It's made of completely different series of chemicals, right? And all of our planets kind of got a different kind of flavor to them. Where if they all settled from the same cloud, yeah, there's different densities and things could be like that, but it doesn't really make sense. We have to kind of force things together. But this allows that all to make sense. So they realized that, and they thought, well, rather than setting up a huge system of bringing energy back to our eventually dead planet, why don't we just become a space-faring species? We'll become a space-faring civilization, because that's what long-term longevity in the scale of the cosmos commands. You can't project your species to live 1 million years or 10 million years or 100 million years if you don't leave your planet. So they did. And so they left and they came here. And they didn't know that we were here, because when they left their planet, we were in the middle of an ice age. We didn't have radios, we didn't have anything. And nobody's going to see smoke signals through a telescope from 10 or 20 or 30 light years away. It's just not a realistic expectation. So when they got here, they figured out, they came in and they explored all the planets. Obviously, they're going to do science like we did. They got here, they sent probes. I got an image of a probe coming to Earth. The first probe, one of them showed me, and it like hit the different layers of the atmosphere as it came in. And they were still using rocket technology at that time. And it came in and it landed on planet Earth, and they found that there was life here, and intelligent life. And they were like, whoa, that's interesting. Well, we've already made our massive plans to come all the way to this solar system, so we're going to stay, and we're going to figure out how to live together. And so they've tried to guide us and steer us passively. They never watched the Gene Roddenberry series, and they don't know of the Prime Directive, where you're not supposed to interfere with species. And so they've made mistakes. They've done things to us. They've created massive amounts of belief systems. I think there's 10,000 different religions on planet Earth, which is like insane. How could they all be true, right? That means that there's like so many gods. I mean, if you think about the amount of life in the universe and the number of different civilizations that there has to be out there, and the number of gods that commands, and all of it just scales up, right? The numbers become insane if they're all true. But it makes perfect sense if they were doing it, if they were feeding that, if they were steering us through that belief system in a way that we could handle. Because imagine trying to convince your dog that space exists. Your dog would be like, you mean like the park? No, like space, where there's no atmosphere. Well, what's an atmosphere? Right now, you're trying to explain space to a dog. It becomes very, very difficult. And so, rather than facing that challenge, which they expressed, that it's frustrating having conversations with us because we're not at that level. We don't understand things good enough to have these real, objective conversations. It was easier for them to communicate with us through religion, through belief. We'll just, like we do this with movies. Oh, we'll make this a plausible scenario by creating this solution. We'll create a warp drive. Now we can, Star Trek works, or Star Wars works, because now we have this way to travel the universe, right? That's fictitious. So it's a lot easier for us to kind of bridge the gap. It was easier for them to bridge the gap for us if they just were gods. It allowed them to do stuff that we don't understand. And they liked that. It leaned into, they were special, and they got worshipped, and they leaned into it. And so they've been steering us through, the entire time they've been here, 10,000 years, our entire recorded history, all the way back to the Aztecs. There's Aztec gods, very prominent. There's no reasonable, rational person would disagree that there were gods in the Aztec culture, or the Mayan culture, or the Roman culture, or the Chinese culture, and it doesn't matter where you go, right? Everywhere around the world, we see the same thing. And so they've been here interacting with us through these methods that they've created that were effective. And so they want us to be neighbors with them in the universe. But we're not very good neighbors. We've been fighting each other in some capacity on this planet the entire time that they've been here. And so we're a very aggressive people, right? And that aggression isn't our fault. Our aggression is bred from what it took to survive an ice age. Imagine when all of the landmass collapses down into an ice age, and the land, actual land at the equator, is a lot less than the rest of the land. So all the species have to fight for survival, and that happens on like a 26 or 24,000 year cycle. Is there's a big reset of life as it gets squished, as an ice age happens, and the ice ages have varying degrees of cold, but every once in a while, you know, on the scale of life, 20,000 years isn't very long on the evolutionary scale. We have to fight for our survival. And so our violence or our aggression is a survival method that is deeply seated in us. It was something that was required. We have to have that gear in us so that when the ice age happens, we can beat out all the other animals that are fighting for the same patch of grass, if that makes sense.
It does,
Right?
and that's fascinating. And my next question, I guess, is how do you think that we beat that? Because in my opinion, in order for us to progress technologically, like if you think about how technology moves, energy density increases, and as we get more advanced, it's a double-edged sword, and our ability to be destructive also advances. So we get to a point where, like, if we don't, if we don't become more benevolent as a species, we can't increase or we can't progress technologically without killing ourselves and destroying the technology. So that's a problem that I see, and that's what I'm working on in terms of the psi phenomenon that I'm trying to research and bring more to public light. What do you think the solution to that is?
So the solution that I've seen through my experiences is the most valuable resource that they have is their ability to communicate with one another at scale. And one of our strongest weaknesses is our ability to communicate at scale. When is the last time you've seen a philosophical conversation in any platform at all about anything about what we should be doing or what we could be doing? We don't talk about it. It's not cool. It's not funded. It's not smart. We spend, I don't know what the U.S. budget is for defense this year, but it's in the billions, could be trillions of dollars. We'll spend all that money on defense, but we won't spend, I think the budget's like $500 million or something like that for philosophy and sociology. Well, we're never going to advance. The wolf that you feed grows strong, right? So if you want to solve conflict through sociology, then you need to fund sociology. You need to create a platform where people can communicate, where the AI drives the argument so that the strongest argument can rise to the top. It doesn't matter where it comes from. That's one of their rules. The strongest argument rises to the top no matter where it comes from. And we need to implement some of the stuff that we can learn. That if that's the greatest argument, we should implement that. If it's something else, we should implement that. And we have some tastings of this. Like X is a good platform, but it's not structured. The AI algorithm prioritizes desire over efficacy, right? It will promote a post that carries a lot of social weight. Lots of people have agreed this person is fun. They like watching this person, and so it drives through attention. The more attention somebody commands, the more attention they will receive. And somebody who's, maybe doesn't care about that as much, a physicist or a scientist, will have a comment on there and it won't go anywhere. And it should carry more weight than any of these, people who aren't trained in those fields. And so we need to create a platform where we can argue at scale. And I have some ideas on how to do that, but I'm trying to do all this on my own. And that's one of the reasons why, that is the only reason actually that I'm taking the public avenue, if that makes sense, is to try and get help, to try and build this. I can't do this on my own. I need the help of humanity to do this, because every one of these things that I want to do is a massive project. Creating a platform where we can argue at scale is a huge deal. That's not like a weekend project that you can do, even with the best AI coding software that's out there. It's not good enough, right? Like, it's just not good enough. It's going to take years of work to create a, like, you know how when you're coding, you can create forks and different people can work on different forks? Well, there's like a massive fork of logic. And the arguments rise to the top, and you figure out which ones are tied to belief and which ones are tied to science. And then you can hone it. And then the ones that have been won don't need to be argued again. We don't need to argue if, you know, you should wear sunscreen. We don't need to argue that. There's enough science and data out there that, you know, I mean, people have an opinion one way, people have an opinion another way, but there's an objective, there's science to validate whether or not it's smart. And that argument should be available. And we're starting to see that with our AI. We can ask our AI, right? Like, how does this work? And it'll give us answers. So we're getting to that point where we can create these type of functions or these type of things where we can do that. And I think that's how we solve a lot of these problems, is by seeing each other and communicating, right? A lot of the conflicts that we have could very easily have been prevented if people knew if people knew the truth of what was going on, number one, and if people had a say in what was going on. Like, I can't imagine that anyone in Russia gave a rat's ass about invading Ukraine. If that would have been a public poll and people had all the information available to them, they would have been like, what? We can't even bring food and plenty to the people that we have right now. We don't need more space. We don't need more land mass, let alone to spend all those resources on collecting some land mass. How about we get better education, or how about we spend that money on schools or healthcare or whatever? And so the average person doesn't make the decisions to go to war, right? Like, they didn't ask America if they wanted to go to war with Iran. They just did it, right? Like, he just made the decision that they're going to do it. We're not going to let them have nuclear weapons or whatever narrative they gave everyone. Whether or not that's true, we don't know, because we're not allowed to have that information. Why are we not allowed to have that information? That should just be public information, so that we can have these types of things. And so there's layers to all of this, right? And we have to just start somewhere and start winning those fights that we need to have in order to create the space that it takes in order to be benevolent to each other.
Yeah, I think that's a wonderful idea, this social media platform, and I want to explore that concept a little bit further. So when you spoke about that, the direction and the intuition that I got is you're just changing what you're optimizing for. Current social media platforms, they're optimizing and like what they're trying to maximize is basically engagement and entertainment. And that's good for two reasons. One, or at least it's good for them. The first reason that it's good is that it's basically a system that's good for business. Like, because if you're optimizing for engagement, you're getting the most eyeballs on, you're increasing watch time, whatever it may be, and then you can monetize through that, through ads or whatever. And then the other thing is it's relatively easy to optimize for because it's easy to quantify. You can quantify, engagement and attention via likes, via comments, via engagement rate, via screen time. It's very easy to quantify for. So my intuition on the platform that you're proposing is you're just optimizing more for truth. And my thought on that is the real problem lies, it's not an non-overcomable problem, but the hard part would be figuring out how to successfully optimize for truth, right?
Absolutely.
Who's the judge? And you brought up an AI. I think that it's hard to have humans optimize for truth, because I think humans would always just divulge or divert into, optimizing for engagement. Yeah, because of bias, right? Which is how it works now. I love that idea. What is your idea on how to optimize for truth? Instead of optimizing for engagement? How would you logistically go about that?
Well, the foundation of having an opinion is you can't have an opinion if you don't know what you're having an opinion about, right? So the AI is really good at doing research. So if I'm watching an argument and I want to and we do it with social weight, if there's an argument that is tied to belief, it can't be proven factually, right? If we can prove it factually, we don't need this. We can define it 2 + 2 = 4. That argument doesn't need social weight. The only arguments that need social weight are tied to belief. right? So we believe that the Schrodinger equation works, and many people believe it. And why? Because of whatever information they've been given, right? So at that point where it's tied to belief, if the AI will give its best, because it's really good at this stuff. It'll say, I think it's, A, or I think it's B. And it'll say that it's this. And if you want to disagree with it, you're more than welcome to, and you can put your social weight on the other side. But you have to go through and look. And once you get to the bottom of the explanation, then you can now have an opinion, right? And you can say why. And then you just create another argument comes on the side that disagrees with the AI. And then when that eventually susses itself out to a node or nodes that can be provable, now you just put a fork together that's no longer tied to belief. And so now that becomes truth. And then it moves on to the next. Now that becomes a foundation point for the next thing, because all of these things, it's like a lattice of truth, right? Like we know that 2 + 2 = 4. And we use math and we use algebra as a strong pillar of our physics, which is then an explanation for another layer of all kinds of stuff. But without that one pillar of understanding and validation, all the rest of it fails, right? And so it allows us to create this massive fork of logic. And when you zoom out, like the pixels are huge, and now you can actually go through and look at it as a structure, and you can see where we need to put work in, because it'll actually present itself as like a three-dimensional image of our understanding of the universe, right? And so when I have this whole fork and I go to sunscreen, I'm like, okay, well, should I wear sunscreen? And now I've got this huge network of because how many times do you think people ask the AI the same question?
1 million times.
All the time. And so it's answering the same questions over and over and over and over and over and over and over again. And if it has this structure, it actually speeds up its ability to respond, because now it has Elon's trying to build a Grokpedia, which is beautiful, and it's amazing that he's doing that, but it needs to be structured in a new way. And I think we let the AI structure it in a way that works for the AI. But I'm a mechanic. I learned computer science from aliens. I'm like the last person people should be asking how to structure a program. But I've spent a lot of time in their world, and they communicate using programming language, they communicate using programming ideas, and so you have to have a foundational understanding of computer science just to communicate with them. And so that's how I've learned a good portion of this, and living in their world and arguing, and I'm learning this because that's how they do it. They have a giant fork of logic and understanding. And when an argument gets won, it'll swoosh. They call it swooshing. It'll like a whole chain or a whole section that was tied to that one node will close, and then that whole rest of that node can close, and they gain a huge understanding of the universe because of one argument that got won way down in the roots, like the Schrodinger equation. Right? Is it valid? Because right now it's just a theory.
And it changes the downstream effects. When you have a root level problem that's solved.
Everything that's tied to it.
Yeah.
That assumption that was made in the black body experiment that led us to that conclusion. Was that correct?
Yeah, Sean, I think that's a wonderful idea. I follow that closely, and I think that that's something worth pursuing. Dude, I could sit here forever and hash out. There's so many things that we didn't even get a chance to touch on. I think we should do a part 2 and go over some of the other ideas. I think that the direction that you're taking with, what you're doing now in terms of trying to put yourself out there and get more in the public light, I think it's the correct way to go about things. I think that it's going to succeed. I think that you're going to, get what you're looking at in terms of progression and getting these ideas on technology and physics and everything out there, getting more educated eyeballs on them. I think that's all going to happen. I think this is wonderful. Let's do this again. I'm going to bounce. I will send you the YouTube video, everything when it's posted. Tell me where people can find you and your stuff, and then also send me the link so I can put it in the description.
For sure. I'm on YouTube at Maximal Truth. And I've got a bunch of stuff on my stories. I keep posting more stuff there all the time. I'm on X, and you can find links to that. We'll put them in the description. And yeah, I'm looking for corroboration. I'm looking for people to test my skin. I want to get biopsies. I want to people who understand light and have spectrum analyzers that they have access to. I would love to corroborate with them. Anything we can do to push the ball forward. You know, everything I got, I want to share with everyone. I'm not trying to monetize any of this stuff. I mean, I have to live, so I have to, you know, keep myself alive. But I want to just improve humanity. I want to take my experience and maximize its efficacy, improving the human condition, improving the human society, improving sociology. I want to apply it all maximally to sociology, and the more people I get to help, the more good and the more of a dent I can make in our entire world. So I appreciate your support.